Hello everyone and welcome back to the C-Cube channel. This is another tier 1 video, so this is for GCSE Maths Foundation students and those wanting to start from absolute basics. So today we're going to be talking about solving linear equations. So this is kind of the next step up from what we've done in the last few sessions, and today we're actually going to see how we can actually solve equations such as these here. These are fairly basic, simple equations to start with, which are called linear equations. So, to begin with, we're going to quickly talk back about unknown variables. So, what I'm talking about here are, things such as x, y, z, any other kind of letter, anything that we don't know of. This is basically an unknown, so we don't know what the value is. The idea with equations, well, the whole goal with equations is we have to try and find out what that value is. So now we're actually going to be trying to find specific values for these letters. Unlike the previous sessions where we just assumed, we just looked at the x's on their own and just left it be. Now we're actually going to try and find what these represent in some equations I should say. So a typical equation follows a standard formula like this here. So we have the expressions on each side, and we have an equals separating them. Now the absolute basic equations always have an expression on the left or on the right, and then just a single number on the other end. So in this case we have the expression on the left, and then we just have a number on the right, or sometimes it could be the other way around. So this is like the simplest equation that you can get. We'll see later on that in fact it turns out that there are in fact expressions on both sides, so 9 on its own is technically an expression, but we'll see why later. So for now, we have here an equation. Is basically what we're saying is we have a number, we don't know what it is, but if you add 4 to it, so if you add on 4, then you get 9. So something plus 4 equals 9. That's the whole premise of equations, is just seeing, okay, well, you do something to it and it gives you a number. So this kind of is essentially just all it is, really. It's just a kind of a puzzle, trying to figure out what the number is. So the idea of solving equations is basically you just have to work backwards. That's the way you could describe it. So the idea of this is you work backwards and you have to try and get the variable on its own on either side. So in this case, our goal is to get x on its own on the left side. So what do we do? Well, what we can do is we see that x plus 4 equals 9. And if you want to get x on its own, clearly you have to do something here. You have to try and get rid of the plus 4. So what we do is we have to try and find a way such that this part here will be 0. Okay? So 4 minus something, or plus something, will equal 0. And in this case, it will be minus 4. Alright? And what you do here is basically you're doing x plus, I'm going to write it down here actually. So the idea is doing x plus 4, whoops, minus 4 equals 9. Now, a key thing to remember with equations is that if you do this to one side, you will have to do it to the other end as well. So it will be 9 minus 4 as well on the other end. And the reason why you do that is because plus 4 minus 4 is equal to 0. And if you had just left 9 on its own, then it would have been x equals 9. But 9 plus 4 is not equal to 9. So that's why you have to bring the minus 4 on the other end as well. So we have minus 4 in both cases. That is the key thing of technically working backwards, you could say. So in the end, what we've done is we've actually just moved the plus 4 to the other side essentially, and just changed the sign. So this can be written because plus 4 minus 4 is 0. Remember that? So we now have 9 minus 4. So this is actually just a rearrangement of what's up here. X plus 4 equals 9. And then x equals 9 minus 4. So we move the 4 to the other end and we put a negative instead of a plus, because of what we've done on the left side to make it equal to 0. And so in this case we can definitely do 9 minus 4 now. And so 9 minus 4 is 5. And we find that x is equal to 5. And we have solved the equation. So that is the standard procedure with equations like this. Now I should note that this is called a linear equation. And what I mean by linear is that we only have a single term here. Or we have a single unknown that we're trying to reach. That is not a square or a cube or a quartic, to the power 4 or any other kind. So basically what this means is that we will only get one answer out of it and nothing else. So that's technically what we mean by linear equations. So it's kind of the starting building point from, the starting point from all of equations. Because later on, we're going to be taking a look into quadratic equations, which is the next step up, where you'd get 2 solutions instead of 1. And then in the future, we'll be looking at things, in the calculus region for the A-level students. We'll be taking a look at solving differential equations, where you can, do all that kind of thing where you have to use calculus. But for now, we're not going to worry about that. I'm getting ahead of myself. So we're just going to start from absolute basics, linear equations. That is the procedure right here. So we've done it for addition. We can also do this for division, multiplication, and subtraction. With subtraction is basically the same procedure as this, except instead of a minus on the other end, it will be a plus instead. So if we had x minus 4 equals 9, then you would bring the minus 4 to the other end and then make it plus. So it's the same procedure, you just swap the signs around. That's it. So let's go to division now. So let's assume this equation here. X divided by 2 equals 4. So x over 2 is equal to 4. Now we have to try and get x on its own. That's what we're always aiming for. Trying to get x on its own here. So what do we do? Well, in this situation, what we can do is we have to try and do something here so we can get x on its own. So we have to get rid of the 2 at the bottom. Now remember that this x over 2 is the same as x multiplied by 1 over 2. Alright, you have to remember that is the same as this. That is exactly, I just said, well, I mean something else, but you get the idea. This is the same as this. So what we did is x multiplied by 1 over 2. So x will go at the top there. And then we have x over 2. So we have to get rid of this half somehow. And the way you can do that is quite simply multiply by 2. So again, we're doing the reverse operation. So remember that addition and subtraction are kind of inverses of each other. And in this case, multiplication and division are also inverses of each other. So if you have to do division here, then you would need to do multiplication to get rid of it. Now, I'm going ahead of myself here, so let me say this again. To get rid of this, we need to multiply by 2. And on both sides, might add, for the same reason as last time. But the reason why you multiply by 2 is because if you do 2 multiplied by 1 over 2, then that means the 2 will go at the top, as to do with multiplication. You got 2 divided by 2, and anything divided by self except for 0 is 1. So we just get 1 from that. And if you have the x in front of that, and you carry the x around all the way, then in the end, you're actually just going to be left with x on its own. Or 1x, but you get the idea, you can get rid of the 1. So if you just bring the x along, you'll see it just get an x on its own. When you multiply by 2, that is. So we're going to change this out, so we're going to get x now on its own. And now we're going to have 4 times 2. Because remember, you're multiplying by 2 on both ends. So now we're going to get 8 on the right hand side. And that is the solution. X is equal to 8. And you can double check this by the way, by putting 8 back in. So 8 divided by 2 is most definitely 4. So the key thing to remember for this is this bit here, where to get rid of something, if you want to multiply by something, or if you want to isolate, I should say, the variable, then you just quite simply multiply by whatever's at the bottom. So if it was to say x divided by 3, oh that's an awful 3, but and if you want to get rid of the x, then you just multiply it by 3, because that will give you 3x over 3, and then the 3's cancel, because 3 divided by 3 is equal to 1, and in the end you're just left with x. So it applies for any kind of number that's under the denominator, as long as you're multiplying by the exact same thing. So that's what we could do with that. Okay, so let's take a look at the next bit now. So this is kind of the reverse now. We now have a multiplication instead. So 3x equals 18. Now, if we want to get rid of the x on its own, then you can probably have already guessed, you just have to divide by 3 on both sides. So remember, we already said 3x divided by 3 is just equal to x, because 3 divided by 3 is 1, so we're just left with x. So in this case, we'll just get x and 18 divided by 3, and 18 over 3 is equal to 6, so x is equal to 6. Done and simple. So that is all there is for this this operation here, multiplication. That's all there is really. If you have a multiplication, then you just quite simply divide through everything. And remember, always divide on both sides. And always do any kind of operation on both sides when trying to isolate the variable, because if you don't, then the answer will not be correct. And also check for the signs as well. The signs are essential, as we will see in the next example. So so this one here, we have a combination of 3 different operations here. So this is kind of combining what we've done in the last 3 slides. So we got 2x over 3 minus 2 equals to 2. So we have to try and get x. We have to try and find the value of x. So let us begin. So there are different. Now you have to kind of be careful here, because these two are separate terms. 2x over 3 and minus 2. These are separate terms. Now I wouldn't jump in and multiply by 3 on both sides, because that would be kind of a mess. You could, but the better way to do this is to try and eliminate the minus 2 first. So we're going to bring minus 2 to the other end. So let's do 2x over 3 is equal to 2 plus 2. Now remember what I said before, you want to try and make this equal to 0 with both plus and minus. So minus 2 plus 2 is equal to 0. And that's why you have 2x over 3 on its own. And we bring in the plus 2 to the other end. So that will be equal to 4. Alright, 2x over 3 is equal to 4. Now, the next step is we have to multiply both of these sides by 3, because of the reasons we said before. So let us do 2x equals to 12. Alright, and now we're going to divide both sides by 2 to get x on its own. So we're going to do x is equal to 6, because we divided by 2 on both ends. So that's a 3-step procedure here. Now there's a faster way of doing that, where when we get to this stage here, instead of doing that method where we multiply by 3 first and then divide by 2, if you want to do a more advanced way, you don't necessarily have to do this, so you can decide to do it this way. This way would be better if you want to check, go through things slowly. To start off with, I would recommend this one first. But if you want to challenge yourself or go a bit quicker, step ahead, you can do a different way. So we could take the same thing, but instead we're going to divide everything by 2 over 3. Because this is actually the same as 2 over 3 x. that is what that is equal to. Alright? So this is actually a similar situation to this, where you would divide, 12 by 2 to get x. And in this case, you can actually just go straight in and divide, you could divide 4 by 2 over 3. So let's do that real quick. So now we're going to have x on its own. Oh, that's a bad x. And we're going to do 4 divided by 2 over 3. Right, and that you'd find is also equal to 6. So if you want to do the calculations on calculator or by hand, you would find that is also equal to 6. So that is a quicker way of doing it. This is a more advanced way. It's more rigorous method as well. It's a bit more, well, it's kind of a shortcut in a way. But I would recommend doing this to start with, this method here with 2. You multiply by 3 first, and then you divide by 2. It'd be better to start off with if you're trying to do these kind of equations, but when you get the hang of it, then you can start doing this method here to kind of just make things quicker. Okay, so let's do one last example. So we now have 3x minus 2 is equal to 2x plus 4. So in this situation, what we have is we have 2 expressions on each side. Now, we haven't seen that with all the others yet, because, we just had expression on the left and then a number on the right. Now we have expressions on both sides. Now, what we do in this situation is we have to group up the like terms together. Now, we've done this in the very first video with grouping like terms, so this is the same procedure. But now we have to use the techniques that we've learned in the previous examples with, bringing values over to the other end and such. So let's begin by putting the x's together. So we're going to do 3x minus 2x and then minus 2 equals 4. Now remember minus 2 because we want to get rid of the 2x on this side. So 2x minus 2x is equal to 0 on this end. So we're just going to be left with 4. And then the 2x goes on this end. Remember that. And now we're going to bring the 2 over to the other end, minus 2. So we're going to get 3x. Oh god, these 3's are getting worse by the day. Oh man. So 3x minus 2x. Now we're going to bring the 2 to the other end. So it's now going to be 4 plus 2. Now you see, what we did here again, we're trying to get this side equal to 0 with the minus 2. So minus 2 plus 2 is 0. And so we eliminated it from the left and moved it to the right, where we get plus 2. And now in this case, we can actually simplify all of this. So 3x minus 2x is just simply x. So we've learnt in the first session. That is a bad one. Let me do that again. There we go. So we learned in the first session, remember, when you got like terms, you could just subtract the coefficients together. Remember, coefficient is the number in front of the variable. So now we just left with x equals, and then on the right side we have, that is not 8, that is 6 in fact. So, x is equal to 6, and that is that solved. And if you want to double check, you could put this value back into the equation, and you should see that both sides would be equal to the same thing. So, that is all I had to say on solving linear equations. That is kind of a foundation to further kind of equations that we'll be doing in the future. It's also a foundation to other methods. The next session we're going to be taking a look at rearranging for the subject, changing subject of a formula, and that uses the same principles that we've done here. So that's kind of with a little bit of extra. So that's going to be kind of an expansion of this, do a bit more practice on that kind of thing. So thank you guys so much for watching, and I'll see you guys in the next video.